So today I will be talking about augmenting your existing mobile backend with Cloud Firestore, and I'll get into that in a minute. Pat's my memory, so if I forget points, Pat will yell out.
And like what he's saying.
Yeah, we might get into an argument, but that's okay. I just wanted to say, Splash has asked me to mention as well that we are also hiring. Where's the?
Everyone's hiring.
Ha! So Splash makes some pretty cool stuff. So they've got like a machine learning team doing generative AI music. They're actually getting AIs to sing. They're also making an Unreal game. We've got a Roblox game. We've got a mobile app, a Flutter mobile app for making music. We do some crazy stuff. And so they're looking for game devs, Roblox devs. Next year, we'll be hiring Flutter devs. So I recommend splashmusic.com. Check out the careers if you are interested. All right, that's my pitch done. Cool. So let's talk about augmenting. And so I wanted to quickly talk about what I mean by augmenting. So typically, Firestore is sold as a database, right? Like you can start up your app and you can have it as your entire database to power your app. And that's not what I'm talking about today. What I'm actually talking about is if you've already got an app and you've already got a backend, you might have an API and it's got some database behind that, and that's your source of truth database. Now I'm talking about actually just like bolting Firestore in as like an extra accessory to use to actually augment the capacities of your backend and get some pretty great wins pretty quick for not a lot of development effort. To give a bit of context, like I've been working primarily in small startups with limited runways for the past 3 years. And so my focus is around shipping things with the minimum, quickly with the minimum amount of engineering effort as possible. And so this is what I talk about first party, third party. Like typically in a startup, if you have some funding, if it's not part of your primary product, then you shouldn't be building it, right? Like if your primary product is not a real-time API, you shouldn't be building a real-time API. You should be building whatever your product is and find some other service to bolt in to give you that real-time API. So anyway, that's kind of where we're talking. That gives you a context of my background. So whatever I say will come from that background. I haven't really ever done enterprisey type development. So I wanted to get an idea of who kind of like the understanding of Firestore in the room. So hands up, everybody who's heard of Firestore. Okay, most people, excellent. Keep your hand up if you've used it. Okay. And production app. Who's used it in a production app? All right, cool. And so of the people who've heard of it and not used it, I'd like some hands on like if you've deliberately avoided it for some reason.
Story.
Yeah. Do you want to, it's Bruce, right?
Yeah.
Bruce, do you want to share why you've avoided it?
I just wanted something a bit simpler, so I went to object store. So I went to a database rather than
cool.
Something not a real database.
The reason I asked that is because Firestore is pretty polarizing in terms of using it as your primary database. If you Google problems with Firestore, there is a long list of people who complain about it for a number of reasons. And I've got my slides around the wrong way, so I'm going to go forward. Like there's two kind of major pitfalls with it, and that's like a lack of abstraction between your users and your data. Like it's really nice to have kind of a bit of a layer where you go back to the API and just say your app hasn't updated, but you need to change your schema. Having an API between it means you can just map the data on the way out and you don't break your app. If your app is attached directly to your database, you're kind of stuck on what you can do. And there's ways to work around that, but it is a major limitation. And we hit that limitation hard in the Splash app. That really slowed us down. It's like we got live on both platforms in 4 months with 1.5 devs using Firestore with Flutter and never experienced anything like that. But then after we've been in production a while and we had to start changing data schemas, then we kind of hit a wall. So that's one big limitation. And the very limited querying capacity is also infuriating. There's no search, there's no, they're kind of crippling limitations. The good thing about it is if you use it the way we'll talk about tonight, those limitations don't really matter because it's not your primary database. It's not your source of truth. And so you still have all of the benefits of your existing database.
But it can be your primary data.
It can be your primary data source if you want it to be. But again, we're focusing tonight on using it to augment your existing app as opposed to using it as your primary source of data. So you'll really know what Firestore is, so I won't spend too much on it. The big things I wanted to highlight is the local persistence and the real time. Like they're the parts that we're going to deal with tonight specifically. I did want to call out, like Firestore is pretty great if you're already in like Firebase. Like most mobile apps I've worked on in agency contexts and in startups, they've generally got Firebase in some capacity. Right? Like you might have Crashlytics in because it's the best crash reporting on mobile, or you might have Google Analytics or something. So it's already kind of partially in your app. And so if you've already got it a little bit, then it's really easy to bolt Firestore on. It's like turn it on in your Firebase console, download a config file, and it's up and running. And then you've got that tool. And so you don't have to integrate extra third-party dependencies. It's already there. Actually, one thing I didn't mention is cost. Cost can be a real drawback. And like there's a lot of factors that come into that, and I'll talk about that at the end. So that's the other reason why people will avoid it, because it's kind of hard to know how much it's going to cost you. But yeah, we'll discuss that as we get towards the end.
That's why I use object store.
Yeah.
It's free. Yeah.
Yeah, and like it's got a good free tier. But when you hit that free tier, it's kind of hard to know, what your costs are going to be. Basically impossible to work out. You've kind of just got to wing it. All right, so I haven't got a slide for this. I'm going to talk about 4 techniques, going from like super easy through to slightly more complicated. And so the first one I want to talk about is dynamic environment variables. Right, so mobile apps. Yeah, cool. All right, that just moved in a weird way. So just about every app is going to have some sort of environment variables. Like I like to put the base URL of my API in my configuration, just in case I want to swap that in the future. It's amazing that that has happened a few times, but also like API keys for third-party services. So in the Splash app, we've got Wiredash for customer error reporting. We've got Revenue Cat for handling abstraction over subscriptions. In Eggy, we've got the Genius Scan, which is part of my demonstrations as why remote config. We had this in the backlog at Eggy for 12 months, and then it became a problem at 12 months because we had to renew our Genius Scan license. You actually have to physically change the key in the app. And so typically in consumer apps, it'll take up to 2 months to get an 80 to 90% penetration of new versions. And some people will not update. Like they won't. They will never update unless you force them to do it because you've got some mechanism built in to force them to update. And so when you've got like a core part of your app, which requires and so in the Eggy app, Genius Scan is the document scanner. It's kind of a big part of the app. And the app just literally starts crashing after that key runs out. And so we didn't have the ability to change this. We had to ship a new build, and it was quite a problem. So obviously these are the ways you can go about it, right? Hard-coded strings. I won't judge you if you've done that. I've done that plenty of times. Build time environment variables with .env files that get loaded in, or you can write your own custom dedicated config API, which is unauthenticated. And so you have one API to get your config, and then you download that, you store that yourself, and then you use that every time to then go and to go and get to your actual API. Those they go from like easy to hard amount of work. I was going to go the dedicated config API route at Eggy, but it was just kind of a bunch of work. So we ended up throwing in the real-time database just for our environment config. And what I'm talking about here, Cloud Firestore and the real-time database, their other database product, are pretty much interchangeable. The reason I'm talking about Firestore is it's just a newer product, and it doesn't have some of the scaling limitations that the real-time database has. It does have some other advantages. Again, we can talk about that. So I've already talked about Genius Scan. At Splash, the Wiredash, the primary account that owned the Wiredash console got deleted. And so our production app, we had people trying to report bugs and they couldn't. And so we literally just jumped into the Firebase console, changed out the API keys and hit go. And then the next time the app launched, it was working again. And it's one of those things you're like, oh, I don't really need it until you need it. And when you need it, it's actually a big problem that needs to be solved. And so this is actually a seriously easy win that you can get just by turning on Firestore and then creating a node for your environment config. And you'd have one in your dev environment, one in your staging, and one in your prod. You put all your keys in there, and then you look it up, and you get persistence for free. So you just literally give it the path, you download it once. Next time you read it, you'll get it off disk first, and then it'll go back to the database and update it. So if you're using any kind of streams, reactive streams, then you just know you're always going to have the correct variables the next time the app loads. It's like, you drop it in, it's done. It's like, I can't believe we took so long to do it at Eggy. So yeah, And yeah, real-time updates and persistence, right? We talked about all that. Cool. So that's technique number one, and that's kind of the low-hanging fruit.
Slightly more security because.
Thank you for yes. Security app check. Yes. If you do an thank you. Pat, what are you doing, man? What am I paying for? If you have like an unauthenticated API, you've got to come up with some of your own authentication mechanism if you want to not have your API keys open to the world. It's probably not a problem. Most config APIs just are completely unauthenticated, but I don't know, I get a bit antsy about it. So you've got to come up with some kind of unique way of identifying your app, whether or not you'd probably grab the bundle ID and then you'd like reverse it and base64 it and then SHA it or something like that. And so your server and your app like know the same way of doing it, but that's a pain. With app check, you can basically jump into Firebase, configure it, and you can say, all right, I only accept traffic from my legitimate mobile apps and specific domains. And so you get that. And not only do you get it for your environment configuration, but you get it for all of your Firebase products. And so again, you've still got to set it up, but it's super easy, and you get all of the engineering might of Google's security team as opposed to you quickly hacking together some random security algorithm.
Which is like considerably big. That can't be understated how good that is.
Yeah, we went through a security audit at Eggy just before we were on a current affair, and like we had this kind of hard launch date, and so we figured we'd go through a security audit. And interestingly, the two things that they said, that because startup, we took shortcuts. I was expecting to get shredded by them, and they said the two things that we did. One of them was using Firebase Auth, not writing our own authentication system. Like they're having like an established authentication system with Google support behind it is one. And the other one was route validators on our API, like simply just schemas for all of our REST API endpoints, because they couldn't do any injection. They couldn't like do NoSQL injection or anything like that because their validators would explode. And that has nothing to do with tonight's talk, but I thought that was an interesting thing to share. All right, so technique number two, which kind of builds on the environment, but it's just a bigger step, like a bigger thing you can do, and that's dynamic static content. And I know I love the dynamic static because that's an oxymoron. So static content in apps is a pain to update. And so the biggest cases where you would hit this, again, I haven't got these slides around the right way, but sales screens, marketing text, and sharing text. If you've got a marketing team and a designer, they're probably going to want to update the text fairly often in the app. If you've got like a subscribe screen, your marketing department or your product manager might want to change that text quite regularly to test different techniques of getting people to subscribe. And so if that's hard-coded in your app, it's kind of painful. Now you can fire up you can use a web view, which is what we did at Eggy at the time, because then you can obviously update as many times as you want. You show the web view. The web views work a lot of the time. If you want to keep it dynamic though, you've got to load the web page. If you've got to load the web page every time, it's a bit of a delay. It's, like it works, and that's the solution that I've used a lot of times, but there's a better way. So a lot of this is the same, right? Like, it's not dynamic. You got to go through the whole process of running new builds. You can't iterate quickly and try new things. Again, you could use a dedicated API for this instead of using Firestore, but then you potentially if you've got a relational database, then you've basically got to set up a table for this kind of thing, and then you've got to add an API endpoint, and that's all kind of slow. If you do it in Firestore, I haven't got any technical stuff here. I'm more talking like high level. Come and see me afterwards if you want to talk technical. Basically, you can just it's a NoSQL database. It's got a console. You can just create a document in it somewhere, call it something, and in your app, subscribe to that, and it can give you all of the strings, spacings, images. It doesn't take much to set up a very basic kind of server-driven UI for static content pages. And so I'm doing this quite a bit in the Splash app now, because like our marketing and designer can't really decide on the text that they're going to use for selling like the subscribe screens. And again, I know they're going to want to change it, and I don't want to have to ship a new version of the app. And honestly, I like building Flutter. I didn't want to have to build a web page for it, because I'd have to fire up some static content side, or set up a Next.js server or something like that. And I'm already working in Flutter. It's kind of easy just to just keep working in Flutter and give them some control, but without making your entire app server driven. Like, this is just pick a screen, pull out your strings, and give them some basic configurability, and then show them how to use it in the Firebase console. You don't even need to build a backend for this to allow them to update it. They can log into Firebase, go to the right place, and change some variables that are already there. And it happens in real time. Like, it's crazy cool. So you can open the development version of your app, and they can have it in the console and change it, and it'll just appear on the phone, and you can change sizes and images. It's really cool. We've got a force update system in the Splash app. So basically, we can say what the minimum version of the app we support is, and it'll just immediately throw up a screen that says, covers everything, says you can't use the app anymore, you need to update, and we can adjust the text and the image and spacing and a whole bunch of things like that. It's really cool. Yeah, and again, like, it's just so easy to set up. If you've got like front end team and a back end team and you don't do much back end, you don't really need the back end team for this. You can just, as a front end team, collaborate, decide where you're putting it. This doesn't matter what your front end stack is either. Like, if you've got Android, like native Android and native iOS, then you've just got to agree on a standard. But if you're using a cross-platform, well, you only got to do it once. And I think persistence is another big call out there, right? First time the data is loaded, next time you load the screen, you'll get the data almost instantly. So you're not going to have a loading spinner sitting there waiting for that data to load. And then after it's given you what it's got cached, it'll immediately then update with what it gets back from the server. Cool. That's that. Did I miss anything, Pat? Cool. I wanted to call out the idea of end config and app config. And so this is what I've called the collections in Firestore. So environment config is things that are specific to an environment and should never be synced between environments. So you don't want your API keys for your dev environment getting synced to your production app. And so, because for app config on the other hand, it's content that you probably want to test before you put it into your production app. And so we have it set up so that the app config collection just gets synced at certain intervals, or we can do it manually. So if the marketing team wants to go in and change the subscription text in the app, they can do it. They can use the dev app. They can see those changes, and then we sync that across to prod as like its own kind of deployment process. And by setting, like, I don't know if you haven't used Firestore, it's kind of a weird structure, but you've basically got unlimited depth, like a JSON tree. And so, basically that's a node end config and has a bunch of documents and collections under it, and app config is the same. And I just know that anything under the app config, I'm probably going to sync between environments. And I need to know that whatever I do in that, I can't break the production app with that. Cool. All right, here's where we start to get into the more fun side of this. And it's interesting that you brought up the offline first side of things. And man, like, offline can be a nightmare. And at Eggy, we completely avoided it. We were like online only, even until I left. Like, we were only just starting to talk about implementing this as I was finishing up. So this is experimental too, just so you all know. So one of the big problems we were having at Eggy is that, can I zoom in a bit? So the Eggy app is like life admin, you sync in your calendars, you can have lists and documents, and it's like a bunch of other apps rolled into one. If you had like 3 calendars synced, it would take like up to 20 seconds for the app to be usable, because as you load the app, it would go back to 3 different Google calendars and pull that data in, and then it'd go to the back end and pull that data in, and you're just sitting there watching the cool little egg jiggle animation, which I put in to entertain myself whilst watching it. It's kind of painful, and people these days are getting pretty fussy with their apps, like especially consumer apps. Like, people are used to things loading instantly. They're used to this being, a good experience and having some offline support. And I think the key is some offline support as opposed to complete offline support. And we'll talk about that in a second. Also, I didn't actually say what I was talking about here. So basically, with Firestore, when you persist something to disk, you get remote backup and device sync pretty much for free. And so the way I'm talking about this is using it as a cache, not as your source of truth. All right, so you've still got your database where you get your data from, and I'll get to a diagram in a second. We're talking about using it just as an extra to that, where I'm adding a persistence layer, and as a byproduct of that persistence layer, I can actually now have multi-device sync working, where I could have the app running on my computer and on my phone and on my tablet and get the changes immediately between all of those. just by writing it to disk on one of them. And so like in Eggy, for example, you could have a list. And so I use another app called TickTick as well for my to-dos. And I always find that if I'm using it on my phone and then I open a computer, it's never quite in sync and it takes a while to update. And so this is an idea of combating that with, again, very little effort. So obviously there's other solutions. Where am I? Obviously for getting over the, you can use a standard persistence library. You could throw it into SQLite. You could use like Realm, which Realm has a sync as well, but I'm not going to go into that now. There's like every platform has a host of like native NoSQL, like basically just JSON caches for your phone, but obviously you don't get any sync with those. And obviously if you're polling actually works. Like we got away with polling in the Eggy app. Again, still polling. But it starts to get really hard to debug because like if you've got two different screens that are visible, especially when you start to get on the desktop, and they're both polling for the same data, and then you've got like a background poll for your application state polling as well. We were having like 5 or 6 network requests happening every second. And it gets out of hand, especially like you're just trying to get stuff done. So you'd be like, all right, I'll just poll for that. I won't check to see if it's already polling somewhere else. I'll just add it in again. And then your logs are just this continual stream of, like I built into the dev menu the ability to turn off polling to be able to actually do any debugging.
And if you think about it from like a performance perspective, if you are going back every minute and asking for an update and you have 1,000 users, you just increase your traffic to your API by 1,000 requests every minute. And
like if you're using Lambdas, fine, it'll handle it. But eventually it'll grow exponentially in cost as you get past your free tiers or you run out of your credit. Yeah. So be wowed at my amazing diagram. Oh, sorry. So basically the solution I'm suggesting here is you continue fetching data the way that you're currently doing it. Obviously, be careful of your polling, but grab your data and just intercept like so whenever you do a write, whenever you do a read from the database, on its way down, just dump it into Firestore. It's already serializable because it's coming over JSON, right? So you just turn into a JSON blob, dump it into Firestore. Now, as soon as you do that, again, it's getting automatically synced up to the cloud, and it's really efficient in the way it does its syncs. Like it will inspect the diff and only sync deltas. And so it's not a high network traffic solution. And then you'll just auto-magically get it on your other devices. It just works. So the way you set this up is instead of using it as like a typical database, again, where you're trying to normalize your data and have not much duplication, this is using it as a cache. And so every single user gets their own JSON node effectively on the server, and you just dump the entire application state in there. And that's that user's backup. And it's really easy to set up security for it as well, because you can basically just say, this user can write to this node and that is it. And so you don't have to have really complex security rules trying to work out who can read to what, because that's actually pretty hard to do in Firestore. Yeah, and it's very time consuming. Whereas this, you just set it up once. It's like, okay, this authenticated user can write to this node, and that's it. And so if you're using Redux or some sort of kind of unified central state management on the front end, you can literally just dump the entire application state in there. And again, it just syncs and it's magical. The thing you're not going to get with this is like a full offline experience. And this is kind of this is where I would cut the line between like 80-20 rule, like you're getting 80% of the way there for 20% of the effort. The app will load. You will get some data with no internet connection. You can't do anything, or you maybe will allow them to have drafts or something like that, which just lives in the cache, because it's not the end of the world. If it's gone, it's just a draft. But for the most part, you're just persisting the data so the user can at least open the app and find something. You know, they might want to and especially in the case of Eggy, right? They might just want to be able to look up a document quickly or quickly check their list. And if they haven't got interconnection, it's kind of a rage moment. And so yeah, this gives you quick boot because you've got the data locally and you can at least read the data, and then you just lock down writing because they don't have internet connection. And again, for most use cases, that's enough. Cool. Let's see how far ahead I've jumped. Yeah, so I've talked about this, storing all data in like a single JSON node per user, and that makes security rules super easy to write. It also makes things sane. Like you just know, each user has its own node. If you want to go looking for it, you know where the data is. I want to emphasize that you need to remember it's just a cache. You need to go and fetch data from the source of truth on a semi-regular basis and update it and just completely blow away what's in the cache, just clobber it. Because it's, you know what I mean? Otherwise you'll start to get drift. Then you've got to start handling sync and diffs. Yeah, and that's when you're really adding a lot of effort for, you know, questionable reward, depending on what your product is. And the other implementation note is if you do have like device specific state, just remember to store that in its own little node based on the device ID. One thing, like notification settings is a big one. Like oftentimes, if I've got the same app on my iPad and on my phone and on my computer, I might only want to get notifications on my phone. I don't want to get harassed in 3 different places. And so I might go in and turn off the notifications on my iPad. But if you're syncing that across all of them, then you're stuck into a single, you know, like a single choice for all of your devices. And there's probably other examples, but I can't think of any. Cool. All right. So, and now we get to the really interesting part. And it's actually like, this is the real magic of this solution. And this kind of builds on the previous one. So like if you were doing this in kind of an MVP implementation, you could work through these from 1 to 4, like start at number 1, start with your environment config, then start doing your dynamic static content. Then you could add in your persistence layer. And now, because you've got this cache, this remote cache, synced up to the cloud, you've actually got a way of talking to your users in real time. And so, you know, we all know this, like Figma, Notion, Google Docs, any chat app, like they all do these real-time communications, but they're not super easy to do. You know, they take quite a lot of effort. If you're building your own like WebSockets implementation, there's a whole bunch of potential scaling issues because so typically like a naive implementation of WebSockets, you'll have a server and a server remembers everybody that's connected to it. And that's great while you have one server. As soon as you've like, so you had 10,000 on the first one, you hit 10,001, that user is on their own on a new instance that's been fired up by Kubernetes cluster, and they can't talk to each other unless you then have some abstraction layer that then keeps track of all of the connections so that you can then go and talk to them. And so you can use something like AWS API Gateway WebSockets, but again, it's not super easy to implement. The documentation is not great. It's definitely doable, and we looked into it at Eggy, but never got to it because it was just one of those too hard baskets. Pusher is like a third-party wrapper over WebSockets, and again, it's a good solution. And if this was your only thing and you weren't too worried about persistence, then it's actually a really good option. It doesn't have great Flutter support, or didn't when I first investigated it, but like its native support is pretty good. But I think the point here is if you've already got Firestore in and you're already using it for other things, you kind of get this real-time push setup for free. You don't get all the work for free, but you at least get the setup. If you're using gRPC or GraphQL subscriptions as your primary like way of communicating with your backend, then this probably isn't relevant to you because you've already got, you know, persistence and caching and real time as baked into those solutions. So yeah, all right, what do we got next? So again, amazing diagram number 2. So this is like a really crude example, but on the other one, I had you save it to the local cache, and then that gets synced between your other devices. In this case, after you've stored it locally, it syncs out to all the other devices, but then you push it up to the API and your API logic gets it. And so if I'm sharing it with Pat, it'll go, okay, cool, this is shared with Pat. So the application logic will go, okay, cool, I know what Pat's user ID is. I'll just go look him up in the database and add it to his list of to-dos. And so next time he opens the app,
or if I'm looking at it right now,
or if you're looking at it right now, it will appear in real time.
Yeah. And
so again, you've just set up local persistence, really. That's the only thing you've really done. And now you have the ability to talk to your users in real time. And like, that's just the starting point. What you can actually do from there is, well, sky's the limit, right? Like you be creative with it.
And it's so cool because you only need to do those like first 3 things. You just need to like have the user on the phone, they need to save it, put it in Firestore, and that entire rest of the flow is handled for you by Firebase, which is like very complex. You
have to write the application logic side of things, obviously. Like you've got to basically, like in your API endpoint that's saving your to-do, you've then got to go, okay, cool, there's 3 other people that are interested in this, and now I need to go and update those people's caches. If you're using push notifications to tell people about these things, you've probably got the basis of that logic in there already. And so it might just be a matter of, okay, I'll send them a push, and they're not online they are online right now, so I'll send it out to them. Or they are online right now, I'll push it out to them, or I'll send them a push because we haven't seen them in a little while. So again, there's still work to be done, but you don't have to worry about any of the infrastructure. And but you've got scalability built in, like it'll just scale infinitely forever for the number of users. Like obviously it's not infinite, but the likelihood of any of us pushing the Google data centers to their limits is very, very unlikely. Yeah, you'll definitely run out of money before you get there. Okay, so implementation notes. So the big one here is you are duplicating your data a lot. As I mentioned before, like there is no normalization here. This is caching at its best, right? You are just gonna, yeah, everybody gets their own copy of things. And so obviously there is cache validation, right? It's a hard problem. And so you need to deal with this. Again, if you're in a simple implementation, it's pretty easy. You just blow away the cache every time you go and update. And so you're getting 80% of the way there for 20% of the effort. There is no, one thing that you get with Pusher, for example, is you can ask if somebody's online and it'll tell you. Is that right? You use Pusher in one of yours?
Yeah, it's got built-in presence detection, but you could easily build that with Firebase.
Yeah, and so the way you do that with Firebase is a heartbeat. You would just like periodically update, like say, I'm here, I'm here, I'm here. They even just updated like TTL, time to live, on Firestore records. So you can actually say expire in 5 seconds, for example. And so you can just check if that key is there. And if it is, you know they're online. If not, well, they've been gone for at least 5 seconds. So a very easy thing to implement, especially since you're already writing to that cache. And if you're just dumping your app state in there, you just update that every time you write. You don't even need to actually add anything else in, any extra API calls or anything like that. You just like add a little flag that updates. And then, yeah, and so basically that's a cost saving measure. If you've got 10,000 users and there's only 50 of them online, instead of doing, 10,000 writes at a time, you can only do 50 because you've only got the 50 that are there. And then you've already, again, if you haven't implemented push yet, well, you've already now got the logic to see who's interested in this thing that's been updated. And so if they're not there, send them a push. Cool. How are we doing? We've got 3 minutes and 37 seconds left. So I've got a lot going on in this screen. I'll go around. So lots of ways to solve these issues, obviously. This is just one take. As I mentioned earlier, bottom right, this is ideas. I've been very light on specifics. I love talking about this stuff though, so hit me up if you're interested in talking about this, if you're going to implement it and you want to talk about the ways that I've gone about do this or any specifics, please just reach out. Happy to have a chat. You'll probably want to stop talking before I want to stop talking. So just so you know, be warned. I really want to quickly talk about money. At Splash, at its peak, we were spending $10,000 a month on Firestore. Now, it should have only been $2,000 or $3,000 a month, but we had some super inefficiencies going on. So we had, when you use Firestore as your actual database, you've got no layer, right? So you need to have triggers on writes to then do validation and update other things. The problem with triggers is they're a pain in the ass to debug. And also, so I update, my user, and then that triggers a function which goes and updates somebody else's user, which then triggers a function. And then you can have this circle of never ending Cloud function. And we didn't care at the time. Like we cared about moving fast. And so we just wore the bill. And the reason we wore the bill was because Firestore was saving us like an entire engineer's worth of effort. We did not need DevOps. We did not need a backend API guy. And so $10,000 a month sounds like a lot, but that's cheaper than a senior engineer. And so that's where cost is relative, right? And again, with very little effort, we could have brought that down to much less than the cost of a senior engineer. And so, horses for courses. If you're in a funded startup, then it's probably not a problem. If you're doing this yourself and you are bootstrapping it, then you might want to think of assess whether or not the cost is going to be manageable. The other one I wanted to call out quickly was Firestore solves a number of problems with a single product. And again, if you've already got Firebase in there and it's just a matter of turning on, I'd say at least assess it, right? I can't tell you if this is right for your project. Like everybody has different requirements, different in their applications. And so I would just say, don't rule it out because if you've heard bad things or, just like assess it, have a go and see if it can actually benefit from any of the techniques we talked about. Thank you. Do we have time for Q&A?
Yeah, of course, yeah.
I think there are 1 minute. So if you want to get your question in the recording, go. Yep.
Do you know what the
network technology behind Firestore is?
gRPC. So yeah, it uses gRPC for its real-time comms. I don't know, like custom database engine or like just, I don't know how they store it on each.
What is gRPC?
gRPC is a custom, like it's Google RPC. So RPC is a different serialization format than JSON. And so gRPC is Google's version of that. And so they have a bunch of client libraries for each platform.